Hello, my dear students. Welcome to this session on YouTube Live by your physics educator Uttam Kumar Umarji. So, very good afternoon, my dear students. Welcome to this beautiful session on work, energy, and power. Now, this session happens to be my third consecutive session on work, energy, and power. If you can notice, so in my previous two sessions, I had covered some interesting problems. Okay, and in today's session, again, I'll take a look at few more interesting and important problems from work, power, and energy. So I heartily welcome one and all for this particular beautiful session called Work, Power, and Energy on Unacademy's YouTube Live platform. I am your physics educator, Uttam Kumar Umarji. I welcome one and all once again. Now, as I was mentioning to you, my name is Uttam Kumar Umarji. In fact, I am an MTech graduate and I have a total of 19 years of experience. I am a verified physics teacher on Unacademy. And talking about my experience, my dear students, in fact, I started working in the field of physics for class 12th, class 11, class 12th physics for JW Advanced and JW Main. Then I have also taught to NEET physics, okay, and all in all, overall, like I have worked for 19 years at Delhi, Kota, Bangalore, and all across India, I can say. Okay, so I have seen diversified people, diversified students, many interesting students also I have met during my tenure, and I am very much happy to address each one of you once again on live platform on YouTube by Unacademy. Now, next, like I've taught almost like close to 10,000 students till date, my dear students. Okay, so you are also one among them now, right now. And then this is presently a fourth month I'm on Unacademy platform. And in fact, these 4 months have been highly relinquishing, and I it had it has given me a lot of energy, a lot of enthusiasm, a lot of love from students on Unacademy platform. I thank you, Unacademy, for providing this wonderful setup. And let us go ahead and thank Unacademy all together. Okay. Then let me just talk about what exactly Unacademy has in store for you. Okay. So now we would like to learn about the Unacademy's Plus subscription. First and foremost thing, as we can see that Unacademy has got Plus subscription plans for almost all courses, almost all entrance exams, and presently now we are going to learn about Unacademy's Plus subscription for Karnataka CET 2021. Okay, so hence let us see like what are the best plans that have been given to you for subscription. Now, subscription plans, just go ahead and observe. We have first subscription plan, that is a 12-month plan, and this 12-month plan, dear students, it would cost 12,375 rupees. Okay, and if you would like to avail an EMI, my dear students, go ahead and avail it by paying 1,031 rupee per month. Okay, so this is very easy, right? 1,031 rupee per month. You can go ahead and avail EMI facility also, right? Okay, then we have a 6-month plan which costs 10,125 rupees, and this is 1,688 rupee per month. Okay, if you would like to go ahead with EMI facility. Then we have thirdly a trial plan, a 1-month plan. Suppose you want to try the platform and then go ahead. Then go with this 1 month plan. 1 month plan would cost 2,250 only. But my dear friends, you cannot avail 1 month plan more than once. Only one time you can avail this 1 month plan here. Okay, so hence it is mentioned here. This is only for new subscribers. Okay, so that means you can avail 1 month plan only once. That's all. Okay. Then what exactly you will be getting out of it? So why you require plus subscription? So if you ask me a question, then I would like to ask you a question back. Okay. Then answer to that. Now suppose you are looking for some premium content. Okay. But you can't spend more. You want at an affordable cost. Now in this situation, dear friends, if you are willing to have such premium content which is worth in lakhs, okay, but if you want to pay a little amount, then go with plus subscription, okay. So premium content at a very much affordable price. Then we have structured live courses. Suppose you want a well structured live course, so, how about like announcing the course, say 4 days or 5 days in advance, so that you all can have a look at it and then get enrolled for that particular course, learn it, okay, then clear all the doubts, okay. If you are looking for such thing, then definitely you would have spent more money, no? So, but here at a very much low cost, okay, you will be getting structured live courses, dedicated live doubt clearing sessions will be there, my dear friends. Okay. Then, thirdly, like quizzes. Suppose you are a geek of a quiz. You want to try your knowledge and you want to know where you stand exactly. Now, in that situation, you would go around and have a look at some online quizzes, is it not? And here on Plus subscription plan, you have quizzes already being present. For every particular course, there will be a quiz, a mega quiz, okay? And based on that mega quiz, you can make your self-analysis, okay? So hence, quizzes are at regular intervals, okay, for self-analysis. Then, if you are looking for a batch which can give you complete preparation. Complete in the sense, all three subjects for engineering stream, or like physics, chemistry, mathematics. Suppose you want all four subjects like physics, chemistry, mathematics, biology. Okay, so that is the complete preparation I'm talking about. So within this subscription, you can get all the subjects, all these four core subjects you can learn under one single subscription plus subscription. So hence we say batches are there for complete preparation, my dear friends. Then test series. Suppose, because for every entrance preparation, test series is a must. And if you are looking for test series, then these test series have been divided into daily practice papers, which we call them as DPPs. Then we have full length mock exams. Okay, so suppose you want such thing, go ahead with the plus subscription simply. Okay, so here we can say that test series containing daily practice papers, full length mocks will come with analysis. That is most important. Your analysis would be known to you the moment you press submit in that DPP or full length mock. Okay, so all in all, we can say one single subscription for unlimited access, right? So hence we can say single subscription for unlimited access. Now this is Unacademy benefit, my dear students. Okay, so now accordingly, as I was mentioning to, there is a live batch which you can go ahead and join that batch and learn completely. Okay, then if you would like to avail a 10% discount here, okay, suppose you want 10% discount, then who will give you that? your teacher, that is me, I will give you 10% discount. That method is use my referral code. My referral code is UTTAMLIVE. Now this is my referral code, my dear friends. So use this referral code. Straight away on the spot you will get 10% discount on whichever plan you are planning to take. Okay, so this is advantage Unacademy, advantage your educator. Okay, so definitely this is beneficial. Okay, so hope you all followed what I wanted to explain regarding class subscription. Now let me just move on to our question. First question. A bomb of 12 kg explodes into two pieces of masses 4 kg and 8 kg. The velocity of 8 kg mass is 6 meter per second. The kinetic energy of the other mass is, okay, so velocity he has asked, and he has asked us to calculate the kinetic energy of the other mass. Okay, so a 12 kg bomb is exploding into how many pieces? Two pieces having masses of how much? 4 kg, 8 kg. Okay, then this is the situation, is it not? Okay, so over here we'll consider initial momentum of the bomb. It was 0 before explosion. Okay, so after explosion it is getting split into two parts. No, before explosion no linear momentum. After explosion it is getting split into two parts. So accordingly we can say from the law of conservation of linear momentum. Okay, final momentum minus initial momentum is 0 here. So hence we can say that both the bodies will have same, numerically same or equal momenta. So this is what I can say here. So hence, what is that? MAVA is equal to MBVB. That is momentum of A, momentum of B. Okay, both of them are equal here. Then accordingly 4 into VA is equal to 8 into 6. Is it not? Because VB is given as 6 meter per second, and mass of B is 8, mass of A is 4, VA is unknown. So we should find that first. So hence we can see that we'll get VA is equal to 12 meter per second, my dear friends. Right? Then accordingly, kinetic energy of the other mass can be half ma into va square. That's all. So hence half 4 into 12 square. Now 12 square is 144. 144 divided by 2 is 72. 72 into 4. Okay. So obviously we will get this as 288 joule. Is it not? So this is the problem that I was talking about. Okay. So the solution is 288 joule is our required answer here. Hope this fits to your understanding. Okay. Now let us progress to our next question quickly. Okay. So if you just talk about second question now, two masses of 1 gram and 4 gram are moving with equal kinetic energies. The ratio of the magnitudes of their linear momenta is, okay. So two masses, 1 gram and 4 gram, moving with equal kinetic energy. So look at this, kinetic energies are equal. Then they're asking us to calculate the ratios of the magnitudes of their linear momenta. That's all. Simple. Okay. So over here we know that linear momentum is equal to square root of 2 into m into kinetic energy. E is kinetic energy here. Okay. Because we know that kinetic energy E is equal to P square by 2m. That formula. Okay. I am utilizing. Hence P has been found here. That is linear momentum. Now over here it is given that energy is constant, suppose. Okay. Then P will become directly proportional to what? Mass. Is it not? So from this I can say that P1 by P2 is equal to square root of M1 by M2. Right? So over here, mass is how much? M1 is 1 gram. M2 is 4 grams, so 1 by 4, that should give me 1 is to 2. So the ratio of linear momenta is 1 is to 2. Now this is the answer that we are looking for, my dear friends. So I hope it is clear to everyone. Now let me just move on to third question. If the kinetic energy of the body is increased by 300%, its momentum will increase by. Okay? A very simple and beautiful question it is. Now, we'll say let initial kinetic energy even as E. Okay? Then final kinetic energy, I'll take it as E2 is equal to E plus 300% of E, because it is given in the problem, no? So 300% increase. So obviously I can write this as 4 times of E, is it not? So it is 4E. Next, we know that P is, that is linear momentum, is directly proportional to square root of kinetic energy. So accordingly, I can write P2 by P1 is equal to square root of E2 by E1. Now E2 is how much? 4E, and E1 is how much? E. So hence we will get square root of 4. Square root of 4 is 2 here. So that is what we have found now. Okay. So finally, therefore P2 becomes equal to what? 2 times of P1. Okay. Now here is the tricky part. Look at it. Now P2 is equal to 2 times of P1. That means I can write it as P1 plus P1. Okay, P1 plus P1 and P1 plus 1 P1. 1 P1 is what? 100%. No, 100% of P1 I can write. Okay, so hence I can say that it is very clearly what is the percentage here. We can comfortably see that 100% increase. Okay, so increase in linear momentum is 100%. Okay, when kinetic energy is increased by 300%. Look at this. Okay, fine. Next question. Question number 4. A free body of mass 8 kg is traveling at 2 meters per second in a straight line. At a certain instant, the body splits into 2 equal parts due to internal explosion, which releases 16 joules of energy. Neither part leaves the original line of motion finally. Okay? Now, over here, we should identify what happens after that. So, option A, they are saying that both parts continue to move in the same direction as that of the original body. Option B is one part comes to rest and the other moves in the same direction as that of the original body. Okay. Then C is one part comes to rest and the other moves in the direction opposite to that of the original body. So option D is given as one part moves in the same direction and the other in the opposite direction to the original body. Now, over here we should identify which one is correct here. So, this is before explosion, as you can notice here. This is before explosion. This is after explosion. Okay, 2 equal parts, 4 kg and 4 kg, as you can notice here. 4 kg and 4 kg moving with velocities v1 and v2 here. Okay, initially velocity of the original ball is 2 meters per second. Okay, so now as the body splits into 2 equal parts due to internal explosion. Okay, so therefore momentum remains conserved. Is it not? Because external force is 0 here. Internal explosion is happening. So obviously here external force is 0. So whenever external force is 0, conservation of linear momentum can be applied. Is it not? So hence we can say 8 into 2, that is momentum before explosion is what? Mass is 8 kg and 2 meters per second is velocity. So 8 into 2, okay, is equal to 4v1 plus 4v2. Therefore, I can very easily see that V1 plus V2 becomes equal to 4. Is it not? Because if I take 4 as common on right hand side, then 4 into bracket V1 plus V2. Now on the left hand side we have 16. So 4 4s are 16. Okay. Then according to law of conservation of energy, initial kinetic energy plus energy released due to explosion, okay, is equal to final kinetic energy of the system. And this is what I am talking about. Okay, I hope this part is clear. So we can see that initial kinetic energy plus energy released due to explosion. If you add them up, that will give rise to what final kinetic energy of the system. Okay, so that means initial kinetic energy is what half m into p square plus energy released is given in the problem and it is 16, right? So it is given as 16 joule is equal to half 4 into v1 square plus half 4 into v2 square. Now over here we will get v1 square plus v2 square is equal to 16. Okay, so now accordingly, now v1 square plus v2 square, you can write it as v1 plus v2 whole square minus 2 v1 v2, and in that v1 plus v2 you substitute as 4. Okay, then you tend to see that you will get v1 v2 value. Then by finding v1 into v2, find v1 minus v2. Okay, according to the formula, v1 minus v2 is equal to v2 whole square is equal to v1 plus v2 minus 4 v1 v2. So apply that, find v1 minus v2, then simultaneously solve these two equations. Okay, so that is the approach, and if we follow that, then we tend to see that we'll get v1 as 4 and v2 as 0 here. Okay, so this is what we are talking about. Okay, so I hope this part is clear. So finally, hence once one part comes to rest and the other moves in the same direction as that of the original body, because how we can say same direction? Here v1 equal to plus 4 it is it not? So positive value. So since the value is positive, obviously we can say that direction is unchanged. Whereas v2 is 0, that means one body will come to rest, velocity is 0. Okay, so this is the option that you have to pick. Okay, I hope it is clear. Next, question number 5 here. Two identical cylindrical vessels with their bases at the same level. Each contains a liquid of density rho. The height of the liquid in one vessel is h1 and that of the other vessel is h2. The area of either base is A, capital A. The work done by gravity in equalizing the levels when the two vessels are connected is. Okay. Now if you just have a look at this, I'll take h as common height. Okay, so h is that common height when they are connected. Okay, then according to conservation of mass, rho into a1 h1 plus rho into a2 h2 is equal to rho into h into a1 plus a2. Is it not? Okay, so accordingly I can write h becomes equal to what? h1 plus h2 divided by 2, because as per given a1 and a2 both of them are equal here, so a1 equal to a2, so therefore comfortably I can write h is equal to what? h1 plus h2 here. Okay, so h1 plus h2 divided by 2. Now accordingly in the next step, as h1 by 2 and h2 by 2 are heights of initial center of gravity of liquid in two vessels, okay, the initial potential energy we should find now. Okay, initial potential energy of the system is ui is equal to h1 into a into rho into g into h1 by 2. Okay, h1 a rho is what? M. mass, okay, into acceleration due to gravity, that is g into h1 by 2. So is it not mgh, my dear students? So hence we have written that, okay. Plus similarly for second cylinder, H2A into rho into H2 by 2 is equal to rho GA into H1 square plus H2 square divided by 2. Okay. Now this is what I am talking about. Okay. Next step. When vessels are connected, the height of center of gravity of liquid in each vessel will be h by 2, because equilibrium height is how much? H, no? So hence its center of gravity will be at h by 2 here. So accordingly, I can comfortably see that h1 plus h2 by 4. Because h is equal to what? h1 plus h2 divided by 2. So hence h I will put as h1 plus h2 by 2. Then the height of center of gravity or position of center of gravity becomes equal to what? h1 plus h2 divided by 4 here. Hope you can follow this. Okay. Next step. Finally, we will calculate now final potential energy of the system. So hence it is UF is equal to, what is the height? H1 plus H2 divided by 2 into A into rho into G into, what is the position of center of gravity? It is H1 plus H2 by 4, no? So that I am substituting as what? H. Okay. Now, accordingly, I'll get this as A into rho into G into H1 plus H2 whole square divided by 4. Okay. Now this is equation number 2 here. So hence work done by gravity, if we calculate here, W is equal to Ui minus Uf, that is 1 by 4 into rho into G into A into bracket 2 into h1 square plus h2 square minus h1 h2 whole square. Is it not? So we have obtained it like this. So if you just expand this, then we tend to see that we'll get this as 1 by 4 into rho GA into h1 minus h2 whole square. Simple. Okay. So this is what we are supposed to find, work done by gravity. Okay. So I hope this particular approach is clear to you all. Now let us move on to sixth question now. Two bodies of different masses, m1 and m2, have equal moments. Their kinetic energies, E1 and E2, are in the ratio. Okay. Equal moments they are saying. So we'll say E is equal to P square by 2m. So accordingly, if bodies possess equal linear momenta, okay, equal linear momenta, in that particular case, I'll say energy is inversely proportional to mass. From this expression I am talking about. From this particular expression, okay. So accordingly, E1 by E2 becomes equal to what? M1 by M2 by M1. Okay. So thus we can comfortably write the answer as M2 by M1 here. Okay. So this is the answer that we are looking for. Now let me just move on to seventh question now. A sphere of mass m moving with velocity v enters a hanging bag of sand and stops. If the mass of the bag is capital M and it is raised by height h, then the velocity of the sphere was. Okay. According to conservation of linear momentum, we can say initial momentum of the sphere is equal to final momentum of the system. Is it not? So hence, initial momentum I will take it as m into capital V, where capital V is velocity of that spherical ball. Okay. So is equal to m plus capital M into velocity of the system. Is it not? Because second case, what is happening? Mass of the sand and mass of the sphere I am considering. So both combined. So hence it is m plus capital M. Then if the system rises up to a height h, then by conservation of energy we can write half m plus capital M into v system square. Velocity of the square of the velocity of the system is equal to small m plus capital M into g into h. Right? So accordingly, velocity of the system, hence it becomes equal to what? Root of 2gh. Okay, so because this small m plus capital M cancels off on either side. Okay, so accordingly I'll get velocity of the system as square root of 2gh. Okay, now using this value in equation number 1, then accordingly I'll get v is equal to what? Capital V is equal to small m plus capital M divided by small m into root 2gh. Okay, so this is the velocity of the sphere initially. So that is what they have asked us. Okay, so with this note, my dear students, I'll end my today's session. Hope it was quite fruitful to you all. You all liked it. Okay, now let us move on and close this session quickly. Thank you one and all. Have a wonderful time.